Yeah, welcome to Easy Learning Tutorial class. Today's lesson, I have this for you today. This is what I have for you today. This is the question. This question is what we have today. We say, what is the magnitude and direction of the electrostatic force acting on Q3? What is the magnitude and direction of the electrostatic force acting on Q3? And this is the question they gave us. So let us tackle this question. Okay, solution. Then before we tackle this question, we have to recall ourselves or remind ourselves of what? Resolution of forces. We say that force is either act on horizontal or vertical. The real force acts on horizontal or vertical. Just like if I want to push this, I push it, the whole energy, I use it to push it. If I want to lift this, I lift it, the whole energy is used. But when a force is inclined at an angle, that force is no more a real force. Why? Because it's not the whole energy is being used. Part of it is being what? Given to horizontal, part of it is given to what? Vertical. Therefore, we have to resolve the force if it's given in a what? If it's inclined at an angle, either an angle to x or an angle to what? Y, vertical y, and what? X. We have to resolve it by looking for its component on x-axis and its component on y-axis. That's what we do to resolve that force. And which force do we do that? When a force is what? Inclined at an angle, we resolve it vertically and what? Horizontal to get the real force. By the time we resolve it vertically and horizontal, we now get the resultant force of it. Therefore, we have reminded ourselves of what? Force resolution. Back to what they asked us. They said we should calculate the force which QA will insert on QC and the QB will insert on QC. That's what they asked us here. Then writing it down, you remember this minus 6.0 microcoulomb simply take me that the charge there is negative. I put it negative. That's minus. This minus is telling me that the charge here is what? Minus. I put it negative. It's negative charge. Then I draw down. This man here, which is positive, simply telling me that the charge here is positive. That's positive charge. Then I draw down. And this man here, which is positive as well, is simply telling me that the charge there is positive. Then I will draw the whole of the hypotenuse. And this one become QA, and this become what? QB, and this one become what? QC. Then looking at it, I have 4.0 meter here, I have 3.0 meter here, which is distance of separation between this and this and this and this. That's the distance of their separation. Are we there? Then now, I remember that this man here is given to me as plus 4.0 microfarad, 0 microcoulomb. And this means 4 times 10 raised to power minus 6 coulomb. This one is given to me as 2.0 microcoulomb, simply means 2 times 10 raised to power minus 6 coulomb. Then here, this man is given to me minus 6.0 microcoulomb, which simply means minus 6 times 10 raised to power minus 6 coulomb. Good. Now, I will resolve this. Let us look at the force. What they asked me, the force that is what? Acting on this man. Then, by looking for the force, which this man will insert on this, and this man will insert on this, meaning that this man is an isolated charge. Look at the one I'm looking for. Isolated charge. This one becomes my text charge, which I hold in my hand, looking for it. This one becomes my text charge, which I hold in my hand, looking for this person. Why this person is an isolated charge, which is movable, is a prodigal son, which we are looking for. Why this one becomes a what? A text charge, which we use, just the dog we used to look for it. Why this one is also the text charge, which I used to look for it. So let us move. Then let me look at the first that they were sent. Then I look at this. We look at this. Let me use diagram here because there's no time. I'm using this force, as I hold this force in my hand, coming closer to this man, what will happen? Can somebody tell me? This is a positive charge, this is a positive charge. As I hold this charge in my hand, coming closer to the field of this man, coming to the field of this man, what will happen? He will what? Push himself away. He will run away because they are the same charge. He will push himself away in this direction. That's on what x-axis. And moving this direction means that the force of what? A, B on what? C. Look at the force of what? B on C. This is the force of this what? B, QB on what? C. That's this language, B on C. Then now, I'm looking at this man. As I'm holding this man at my hand with my text charge, looking for this particular man, what happened? These and this, they are of different charge. What will happen? This man will move from where he is and come to my hand and magnets to this one. Immediately I come to his what field, what will happen? It will come to my hand. Just like that. Meaning that this man will move in this direction. Look at the direction it will move. It will move this direction. Are you following what I'm talking about? And the force will now become what? F. F A on what? C. That's the force of what? A on what? C. That's what it's going to be. Then this implies that the forces I have there is this way and what? This way. I think you're following what I'm doing. This is the force I have there and I have an angle here. And what is the angle? I needed to know the angle here. For me to get this angle, I needed to know this angle here. I'll be able to get this. Therefore, I needed the distance of separation between this force and between this charge and this charge. Distance of separation between this charge and this charge, which I didn't have here. They didn't give it to me here. Look at distance of separation between this charge and this charge is not given to me here. Then for me to get it, what will I do? I have to apply what? Pythagorean theory. Look at this and this are given. This is not given to me. Hypotenuse is not given to me. So I have to apply Pythagorean theory. By Pythagorean theory, I have that, I call this one x. Remember? Let me call it x. And I'll say that what? X squared is equals to this man what? Squared plus this man squared. And that will give me, coming over here, that will give me that x is equals to square root of 4 squared plus 3 squared. That gives me square root of what? 25. This is 16, this is 9, giving me 25, that gives me what? 5 meter. Distance of separation between this and this is what? 5 meter. Then let us look at the angle here. I don't know the angle. The angle which this man had here. I don't know the angle. So let us look at the angle there. And I remember that this is the same as this. Look at the line here. Are you get what I'm saying? And that's this angle, which is what? Theta. And this man is what? Theta. Looking at it, watch. And this angle is this theta. If I get this theta, I will do what? Line, angle on a straight line and be able to get this angle. Then let us move. Then I cannot say that was getting this angle, I can say, look at here, I can say what? This over what? Adjacent. This angle over adjacent, opposite over adjacent, which is giving me what? Tan. I can now say what? 4 over 3 will give me what? Tan. Will give me tan. Tan what? Theta. And that implies that what? For tan theta, that implies tan theta is equals to 4 divided by 3 will give me 1.3333. Then theta itself will give me tan inverse of 1.3333. and that will give me equals to tan inverse of 1.33 will give me what? 53.1 degree. That means that theta is equals to 53.1 degree. I have gotten this angle. I've gotten this angle. Then now to get this angle, I cannot say that what? I cannot say that this angle become what I'm going to have as this angle here will be theta plus this angle, which I'm trying to resolve horizontal and vertical. So now, since I've gotten this angle, I have to resolve this force. This force is inclined at an angle. This one is in the horizontal. And what's this force? This one is what? F A on C. Why this one is a F B on C. That's the force of this. The one that move FB on C, this one FA on C. This one is a ray force. This one is inclined at an angle. I have to resolve it. I have this. Look at what we have here. And this. And I have this. I want to resolve it. And this angle here is 53.1. And I have horizontal. Look at the horizontal. Look at the what? Horizontal as well. Then this one here, I'm going to call it what? FA on 3 on a C X. Why this one become what? XY. This one become FA on C Y and X. This is for X axis. This is for X axis. Okay. Let's clear it. Let me draw it. Let me draw it properly for you to understand it really. For you to understand it really. I have this. Look at the force. Watch the force. Look at this. And look at this. And this is what's 53.1. This side parts is become the ray force, the force which is FA on C as FA on C. I'm resolving this man vertically. I will have FA on CY. Resolving this man horizontal, I will have FA on CX. Then now, this man, which is vertical, if I want to resolve it, I will say adjacent over hypotenuse. That gives me that FACX is equals to FAC times cos 53.1. Then for this man will be FA on C Y is equals to FA on C times sine 53.1. Somebody will say how? Look at it. Adjacent over hypotenuse. What is hypotenuse? This. What is adjacent to this? It becomes adjacent over hypotenuse, which is FACX all over FA on C equals to what? Cos 53.1. Making this subject of form, I have FACX equals to FAC times cos 53. The same thing is done here. Opposite over hypotenuse. That gives me sine. If you see opposite, what is opposite? Look at it. This opposite. Opposite over hypotenuse FACY all over hypotenuse FAC equals to sine 53.1. Making this subject of formula, I will have this. I have resolved this both vertically and horizontal. Then that lead me that I needed to know my what? FAC. I will now say that what? FAC equals to what? QC all over what? Distance of separation. And you remember that my what? My K is 9 times 10 raised to power 9. That's for K. Times QA. QA is given to me as minus 6.0 microcoulomb. Will I use that minus anymore? No. The minus there is only telling me that what the charge is what negative. And the minus there is only telling me the what the direction. Why? You know that the charge is a vector quantity which has what magnitude and direction. And with this direction, I'll be able to know the direction of force. So I'm no longer using that minus anymore because I've gotten the direction of force, which is sign there is there to indicate for me. What I'm going to use there is only the magnitude, 6 times 10 raised to the power minus 6 times QC. QC is what 2 times 10 raised to the power minus 6 divided by distance of separation. What is the distance of separation? This and this, which is x, and that is what we call it to be what 5 all what squared. Then this is the time you bring out your calculator. Bring out your calculator. When you bring out your calculator, you open bracket, you write 9, you press what? Shift, you press log, you press 9, you press times, press 6, press shift, press log, press minus 6, you press shift again, press 2 times 2, shift, log, minus 3, minus 6, close the bracket, you do this, you open bracket, immediately you close the bracket, you do this, divide by 5, you now press this in your calculator, you see this in your calculator, press it, it will appear to here, then press equals to, by the time you press equals to, you will have this A on C is equals to, what you're going to have A on C is going to have to be, A on C is going to be, what you're going to have is, A on C you have 4, A on C 4.32 times 10 raised to the power minus 3n. That's what you're going to have there. When you have done that, you will have that in that. Then now, what's the next? You will now begin to look for this. I'm looking for what? FA on C x is equals to FA on C times cos 53.1, which is equals to, I have gotten this man, which is what? Which is 4, which is 4.32 times 10 raised to the power minus 3. Then times the cos, times 10 raised to the power minus 3 times 10 raised to the power minus 3 times the cos 53.1. By the time I have done that, using your calculator, you will have FA on CX will give you, what's going to give you is what? 2.59 times 10 raised to the power minus 3 Newton. I've gotten that for the x-axis of that what force. We have to get for y. I have to claim this place to get for y. Let's get for y so that we get our answer finally. Then now, I'll say it again. This place, which is what FA on what CY is equals to what FAC times sine of what 53.1, which is equals to, I have gotten this man to be 4.3, that's this man, 4.32 times 10 raised to the power minus what 3 times sine 53.1. By the time you times it, you will have FACY to be 3.45 times 10 raised to the power minus 3 nothing. That's what we have there. So when we have done that, the next thing is to have FBC. I've gotten that. The next thing we're going to have is to have what? FBC. What is our FBC? The force, which is what? This man will insert on what? The force, which this man will insert on what? C. The force, which this man will insert on C. That's what we are looking for now. We said FBC. FBC is equals to what? QB. No, that is our constant K. Q what? B. And what? QC all over what? R squared, distance of separation. Then that gives me 9 times 10 raised to power 9 times, what's my B? QB. QB is what? 4 times 10 raised to power minus 6. What's my C? QC is what? 2 times 10 raised to power minus 6. Divide by distance of separation. Look at it. Distance of separation, this and this is what? 3. I have what? 3, all what? Square. And by doing so, if you use your calculator to do that as I've explained before, if you use your calculator to do that as I've explained before, open bracket 9 shift log times 4 shift log minus 6 times 2 shift log minus 6, close the bracket, open, divide, open 3, close, raised to power 2, press equals to. What you're going to have is what? 8.8 times 10 raised to power minus 3 nothing. That's what we are going to have when you are using your calculator to do that. Then now, by the time we have done this, our forces will look this way. Can I clean this? Let's clean this to explain more about this. Our forces will look this way. After you have done that, you see that the forces will be this way. This one, you have resolved it. This goes this way, and this goes this way. Look at the forces. This one become what? The force of what? F of A on C, Y. That's the F on A on C, Y. The force of what? A, Q, A. You know that we resolve this horizontally, resolve it vertically. We resolve this man horizontal, which is this way, and vertical. So this one become the force, which is F, A on what? C, Y. This one is X, sorry, is X. This is what? X, not Y. Is X axis. Then now, this man now is what? FBC. FBC. Look at here. This is the one we have resolved. This man will resolve it horizontal, vertical. Look at it, vertical. Look at it, horizontal, vertical, horizontal. This particular one. Look at this. Look at this. This man, vertical, horizontal. Look at it, vertical, horizontal. Then this man, look at it. Then what do we have this man for? You will see that these two forces are moving in opposite direction. This and this are moving in opposite direction. And since they are moving in opposite direction, we have this, that this minus this depends on the one that is greater than each other. I look for this man, look at 8 point this, 8 times 10 raised to power minus what? 3. Let's all look for this man, which is what? FAC. Look at this, FA, where is it? FAC, okay, look at it here. We'll see that is what? 2.59 times 10 raised to power minus 8. That's for this man here. And you see that this is less than this man. This man is greater than this. So we use this to subtract. Then we will say that what this implies that our forces will be this way, dx, and what? Dx. And how do we get it? You will not say what? This minus this. What do you mean? I said what? 8.8 times 10 raised to power minus 3 minus 2.59 times 10 raised to power minus 3. This minus this force minus this give me the same direction. This might remain what it takes. What it takes is what? 3.45 times 10 raised to power minus 3. That's it. Are you get what I'm saying? I've subtracted this to this. I subtracted this from this. I have this. So by the time you subtract it, you are going to have this force. You are going to have this force. By the time you subtract it, we are going to have that this man become this. We are going to have this and this. You follow? Then, if you resolve this, this is something as what? This. And what? This. There's another way I can write this. You know that this is moving this way, this is moving this way. This one for this one for this. Resultant force will cancel it. What do we call resultant force? The force that cancel the 2 or 3 force. Look at my resultant force. Then this is what we call FR, which is the next force. FR, which is what? Next force. And next force, what is this man? By the time you subtract this man, by the time you subtract him, you will have 5 5.41 times 10 raised to power minus 3. That's what we are going to be looking at this way. For this man, which is vertical, we know him as what? 3.45 times 10 raised to power 3.45 is become 3.45 times 10 raised to power minus 3. Are you get what I'm saying? Then using Pythagorean theorem here to get R, FR will now be equals to square root of what? 5.41 times 10 raised to power minus 3, all what? Squared plus 3.45 times 10 raised to power minus 3, all squared. You get it? So by the time we have done that, we are going to have this. Let me clean the equation. Let me clean the equation so that we'll be able to use this fix here to complete what we are doing. So what we are going to have now, I'll have that the next force, which is FR, is equals to force on what? C is equals to, when you do that, you are going to have that what? 6.4 times 10 raised to the power minus 3 Newton. That's what we are going to have according to my own calculator. If you use your calculator, it will tell you something. Then now, and that's the force on Q3, which is the axis. Then the second question said the direction. What's the direction? The direction is this. Look at the diagram. The direction is the angle which the resultant force makes with what? X-axis. The angle which the resultant force makes with X-axis. Look at X-axis. Look at the angle he made with the X-axis. We say resultant force whenever we are resolving a force. G, direction of force or direction of resultant force is always the angle which he made with X-axis. And what is this angle? We'll call it phi. So looking at it, if I want to calculate this, it will be tan. That means I will say opposite over adjacent. That gives me what? Tan. I will say opposite, which means that what? Tan phi is opposite. What's the opposite? 3.45 times 10 raised to power 3.45 times 10 raised to power minus 3. Look at it here. 3.45 times 10 raised to power minus 3 all over adjacent, which is 5.41 times 10 raised to power minus 3 as well. Look at here. You watch it 5.41. Remember how we get this minus this. Then now, by the time we do that, what we are going to have here, by the time we divide, according to my calculator, 0.6377. I will then say that what tan phi is equals to 0.6377. Then phi is equals to tan inverse of 0.6377, and the phi is equals to 32.5. What is the direction? We said is what? 32.5 below. 32.5 below the what? The direction is 32.5 degree. That's our answer here. You will now see that what? The direction of the force is the angle made with what? The horizontal. That's the angle of the direction of the force. And now we have calculated the force which is started on C and also its direction. And this is what I have for you today. If you love what we are doing in this class, subscribe, share, comment, and that's what we'll have for you today. Thank you.